Hi, everybody. Thanks for attending the talk. Today, we're going to be talking about an interesting topic using Kubernetes to make cellular data plans cheaper for 50 million users. The key takeaway that we want to have folks who are listening to this talk is that a lot of cellular infrastructure, which has been traditionally monolithic and running on custom ASIC and hardware based appliances, is sort of now migrating to an x86 based infrastructure. And so there's significant synergy between these new type of NFV workloads that are coming up and having a consistent underlay that is basically offered by Kubernetes. So today we're going to cover do a deep dive on a project called Magma. And then Chandra, who I'm co-presenting with, will also do a demo on a Wi-Fi use case, which is one of the manifestations of the Converge core project called Magma. A little bit about myself. I'm Amar Padmanabhan. I'm an engineer on the Magma project. I work in the Facebook connectivity team. And then with me co-presenting is Chandra. He's a senior DevOps engineer, and we closely work together on a bunch of our deployments, and Chandra is with Mirantis. So at a high level, what does it mean to offer connectivity to the next 50 million? Models have actually saturated the way that connectivity is being offered. And so the problem of connecting the next 50 million onto a faster internet is a problem of heterogeneity. This is heterogeneity in access. This means like people are getting on the internet over Wi-Fi, getting onto the internet over LTE, and now are getting onto the internet over 5G as well. There's heterogeneity in backhaul. In certain rural cases, it may be satellite. In more urban cases, you have fiber. And then in peri-urban cases, there can be more interesting things like microwave. And then there's also a lot of differences in terms of scale and business models. For example, today, if you look at a traditional carriers network, whether you're looking at downtown New York or rural parts of like Peru, the network looks exactly the same. But the business models and the amount of money that a person sort of can afford to come onto the internet is actually very different. So instead of having everyone adapt to a network architecture that is static, we think that offering the flexibility to offer more heterogeneity in terms of network architectures is the way forward. And that is what will sort of bring the next level of innovation in, connecting the next 50 million users onto a faster internet. So a couple of things that we want to talk about here. So the first trend is about the decomposition of a network into an edge and a fabric and how this played out in the data center. We heavily borrow from our experiences both in the Facebook data center as well as watching the industry evolve. And then the second one is now that this decomposition has happened, the importance of orchestration and the importance that Kubernetes has in sort of affording a uniform platform for sort of enabling this orchestration. So the edge versus fabric decomposition. Right, so historically, what the data center has looked like, and even if you go like 5-6 years ago in the Facebook data center, we sort of had hierarchical networks. What this meant was that the network had these multi-$100,000 appliances that were dedicated and offering specific services that were in the network, and these were choke point devices. So any traffic that a user who's trying to access Facebook is generating is having to get routed through these these choke point devices. So this naturally forces a topology. The equivalent is like if you're in San Francisco and you have to direct all traffic, car traffic through a traffic light, right? So this is suboptimal from a topological standpoint. The other thing is, given that the data demands are increasing, the nature of traffic that these middle box devices need to support has to become much faster, and they need to do so offering rich policies. So this naturally resulted in these access becoming really expensive. Fast forward a few years, and this picture is from our data center a couple of years ago. We sort of moved into a sort of a decomposed model of the network, where there is a fabric which is only responsible for moving packets really fast, and then there is an edge which is typically x86 based, where all your services like your load balancers and your firewalls sort of got implemented. So what is an edge service good for? It's fundamentally distributed. So it makes a good candidate for x86. And this is where a lot of the containerization has happened in terms of networking workloads. Software-only policy enforcement points allow for rapid iteration, and that's why all the web scale companies are sort of fully on board with this model. Also, this resulted in having more programmable interfaces like OpenFlow and eBPF that allowed to push through innovation, right? And distributed services are fundamentally harder to manage. And so a lot of the problem became about operationalizing the solution as opposed to actually building the solution, which was where the traditional sort of networking problem space was. So if you draw the parallel in today's LTE or GSM architecture, there are these choke point devices. Some of you are not familiar with these acronyms, but they're typically like packet gateways and MMEs. These are all like large boxes that are pretty centralized. So they suffer from the same exact problem that the data center had. So our argument or our thesis here is that, given the learnings that we've had from the data center and the industry as a whole on the networking side, we think that modularizing the cellular network is actually the way forward for enabling the heterogeneity that we need. So the first and key point is distribute policy enforcement point. This lets you build the ideal network topology that is required for your network. Say you have if you're deploying in rural Peru or something, you may need a different network topology from that of a very dense stadium. And so being able to adapt for either of them is pretty critical. Moving policy enforcement to software has a strategic advantage, and this sort of can spur innovation. And keeping the core network simple and just purely about moving IP packets makes it much cheaper to sort of achieve. So, bringing down the cost, enabling the right topology and innovation is sort of the central thesis of what we're proposing. Now, given this framing, focusing on operationalizing this distributed network is the key sort of computer science problem ahead of us. And this is where, we think that Kubernetes and the VNFs that we're sort of building have a natural amount of synergy. So it's a distributed services problem across multiple edge locations at the end of the day. And having a consistent runtime for achieving that is actually pretty critical. So looking at the architecture, we have something called a converged core that supports Wi-Fi, LTE, or 5G. And this can be deployed at any point, whether it's at the ultra-rural edge of the cell or into a public cloud or into a private cloud and into edge clusters. So finally, what the problem has now translated to is the high-level problem that we're trying to build with the Orchestrator is managing a fleet of heterogeneous edge-deployed service meshes for core convergence. What does this actually mean? Like an orchestrator is a sort of an abstraction that tries to declaratively configure an edge fleet from a centralized management. What was historically like a single device, like a network device, like a packet gateway, is now 50 or 100 packet gateways that are distributed across geographically disparate locations. And so being able to orchestrate all of these things from a central location is a key concept that we think is going to keep the OpEx still manageable, regardless of the size of the deployment. The second principle that we really believe in, and a lot of it came from even the way that Kubernetes itself is designed, is that you sort of build on level triggers. So you always push state and not procedures. So you declare the desired topology for your fleet at the edge and rely on the edge to actually enforce the services and the bring up and the the lifecycle management of it. And by delegation of the procedural control to the edge, you're sort of making yourself fairly tolerant to WAN type outages and being able to centralize the orchestrator. So operationally, having the edge be independent is actually a pretty nice characteristic of a cellular network or a connectivity network. So the orchestrator has two sort of large components. There is an edge control plane. This one is one instance per managed device. So this is the most shrunk form factor where we run the edge control plane on a single node, which is like a 2U box. And it applies configuration updates based on the local mesh and lifecycle manages the services. It ships local state and operational history onto the central controller. And so the central controller has sort of global awareness of what is happening across a lot of the edges. What we've sort of embarked on as we moving from the ultra-rural to the peri-urban sort of scenarios is where we start running on edge clusters. And this is where we think, there's a lot of synergy between us moving into a K8s based model where, there's Kubernetes operators where we leverage and still go with our declarative approach of pushing state and having the edge Kubernetes cluster sort of orchestrate the lifecycle and the management of these edge services. The central management plane, which is typically running in a cloud, is a singleton multi-tenant cloud application that is natively built on Kubernetes. It aggregates stats and histories from the edge fleet. The idea is that we want to make sure that we're not adding a significant level of complexity just because we started distributing these services. And it also exposes endpoints to query information from these distributed services. So this allows operators to integrate into their existing OSS and network monitoring systems in order to continue to manage the core elements just the way they would have managed it today with these choke point devices. The other thing worth noting is that it comes with a bunch of batteries included. So there are multi-tenant wrappers around Grafana, and then we use Prometheus as our time series. We also use Elastic for log export, and then there's a basic REST authorization framework that allows you to access APIs as well as a UI for interacting with the system as a whole. Clearly, we are not isolated as a core, and we need to operate with other systems in the network, and so there are integration points offered for time series and even data syncs that Chandra will sort of briefly also cover in his set of slides. So Chandra is now going to talk to you about the Magma integration with the Mirantis Cloud platform. The focus of this part of the presentation, as well as the demo that is to follow, is around the Wi-Fi mobile data offload use case, which is a sliver of the access technologies that we support on the Magma Converge core, along with LTE as well. Over to you, Chandra. Thank you.
Thank you, Amar. So here I will be talking about Mirantis Cloud platform and Edge Cloud and how we integrate Magma on top of Edge Cloud. So I want to talk overview of MCP, which we call it as Mirantis Cloud Platform. It is an enterprise-grade open cloud software, so which consists of 3 components. On the right side, you can see it's a Stacklight, which is our LMA tool. On the left side, it's a drivetrain, which is our LCM, which is used for your day 0, day 1, day 2 operations. And the middle part, it is an infrastructure stack, which comes with a lot of tuned stacks like OpenStack, Kubernetes, Ceph. So now I want to discuss a little bit more about MCP Edge architects. So here we have a minimum footprint of 4 nodes where you have your Kubernetes master on HA and on the worker node where you run your existing Magma core. So I want to talk more about MCP Edge where we use only Kubernetes for managing both the VMs and the Docker containers workload. So all Kubernetes services are HA, but it's a small footprint with only 4 nodes here. So here we run a mixture of workload, which I was talking previously, both like a VM workload and the Docker-based container workload. So this is possible using our open software project called as Wortlet. So I will be talking more about Wortlet tool in my next slide. So Wortlet. So this is a most important component on MCP Edge, which I will be talking now. So in Kubernetes is capable of supporting the container runtime interfaces like Docker, Containerd, RKT. So Wortlet is a CRI plugin for Kubernetes that can do 2 important things that most CRIs can't. So it can run VMs as a pods, and also it can run with other CRIs in parallel. That is, it enables Kubelet to run multiple CRIs at the same time. It's completely transparent way. And also it can run both Containerd workload and Cow2 based VMs on the same compute node or worker node. So here is the worklet architecture or the flow, how it is connected and talks between the components. And when you differentiate the worklet with existing Kubernetes manifest, the both manifest the same. Kubernetes supports all standard Kubernetes objects such as deployment, replica set, daemon set, and so on. So now I will be talking more about Magma integration with MCP Edge. In this demo, we will be seeing the carrier Wi-Fi offloading. So why we are going with that on MCP Edge and with Magma? So to get seamless user experience, optimize the business platform and Wi-Fi ecosystem. And here is the high-level integration part with the mobile core. You can see there is an intelligent connection steering happens between your mobile packet core and the carrier Wi-Fi packet core, which is built on Magma and runs on top of MCP Edge. So the MCP Edge architecture looks like this. So where you have 3 control plane nodes, where you have a drivetrain, stack light, and Kubernetes master on top of that on HA part. And on worker nodes, you have the Magma components like Orchestrator, Federation Gateway, and Access Gateways. So which I will be talking more about them in the next slide. In this demo, what we are going to cover, so I'll be deploying MySQL pods in HA. I will be deploying a Magma orchestrator on HA, also I'll be deploying the Federation Gateway as a VM using Wordlet. This is also on a HA like active standby. I'll be deploying Wi-Fi access gateway as a VM using Wordlet on Kubernetes. Next, I will be connecting to the hotspot and access the internet from mobile. So, and then which is not covered here. So we deployed access point for this demo, but I'm not going to show you how we deploy it and how we are going to configure it. And also we are not going to see how the user provisioning is happening at HSS, PCRF, and OCS side. So when we go into the demo part, I just want to talk about what is Magma Orchestrator, very high level. So it is a cloud service that provides a simple and consistent way to configure and maintain the wireless network securely. And when it comes to the Federation Gateway, it acts as a proxy between the Magma and your existing MNO core network. And comes to the access gateway, it acts as a radio server, or it acts as a metering, and also it has OVS, which will be doing all this metering stuff. And also we have a AAA server which acts as gateway between the user and the internet. So next, I'll be moving to the very, very high level, how we are deploying all the components here on MCP Edge. So initially, this will be the flow. I have a 3 node bare metals right now. So initially, I'll be deploying MySQL pods on 3 nodes on a HA. Next, I'll be deploying a Magma orchestrator with the NMS, which we call as a network monitoring system, which will be the UI to access your orchestrator, Magma orchestrator. So once that is done, I'll be deploying Federation Gateway on my 2nd node with help of Wordlet, and I do have a CNI plugins here, and I have 2 plugins attached to the VM. One is connected to your existing MNO core. And the 3rd node, which I'm going to deploy carrier Wi-Fi gateway. Here we have 3 CNI plugins. One plugin is connected, one interface is connected to the Wi-Fi access point. Another one is connected to the internet gateway. Yeah. So I'll be playing the video now. So which will see all this. So here you can see the video. Right now I'm deploying, I have an automation script which will be deploying all the flow which we discussed earlier. So now we are deploying MariaDB and HA. So we use Helm charts to deploy all the components here, and we automate everything. So it takes a couple of minutes to bring up the MariaDB. So once that is up, there will be a bootstrapping process to create a bunch of users. Here the pods are up, and now the bootstrapping process is happening where it creates a bunch of users, which will be used to bootstrap the Magma deployment. So once that is done, we are going to deploy here Orchestrator, which is again will be on HA, like we have 2 replica sets for each service. So once the Orchestrator is up, it will take a couple of minutes to bootstrap. Now it's moved to the Federation gateway. So we will be deploying 2 gateways here to maintain HA. One will be active, another one will be the standby. So now you can see we are going to the second Federation gateway deployment. So once that is up, it takes a bunch of minutes to do the bootstrapping process within the VM virtual machine. Meanwhile, our automation scripts will continue going forward, installing the carrier Wi-Fi gateway. So this will be our carrier Wi-Fi gateway deployment. So once this is done, it will do a final bootstrapping process where it will create the user account, the admin user account, to get into the NMS dashboard. So we are in the final stage of bootstrapping process. So now the automation script will do the user creation. Yeah, we are done with the bootstrapping. So now let's get into the NMS, the dashboard, where we will be creating the networks for isolating 2 gateways, different gateways, and then we will register the gateways which you just created, and then we will proceed with the final part of the demo. So I'm going to access the NMS dashboard, which is Magma Orchestrator, which will be used to control your all the nodes and even to do the day-to-day, day 1 and day 2 work. Even you can do the upgrades from this NMS dashboard remotely. So I am into the dashboard here. So initially I'll be creating the networks. So first I will be creating the Federation Gateway network, which will be used to register and manage your Federation gateways. So here the Federation gateways acts like a proxy between your Magma core and your MNO existing core. So I'm going to register the second gateway. So once the gateway is created, we need to get back to the particular network, and then we need to register the gateways. Okay, so now I created 2 networks. One is network 1, which is used for Federation, and I'm creating network 2, which will be used for carrier Wi-Fi. Now I am into the network 1, where I'm going to register my Federation gateways. So I'm going to name it as FEC01 and the description. And I will be getting the hardware unique ID from the VM which I just created. So I got it already. So I'm just going to paste it here. The same thing, the challenging key also I will be getting from the VM which I just bootstrapped in my previous step. So I have to give some unique gateway ID to differentiate the gateways, and the upgrade tier as a default. The similar way I will be creating the second gateway. So I will name it as a FEC01 for the demo purpose. And the same, I already got the hardware UAID from my from the VM which I just spinned up previously. The same challenging key I got already from the VM. So I will use the upgrade trier as the default here also. Yeah. Now both gateways are created. So it will take around 30 seconds to get the status. Yeah. So both gateways are active now. So now I think we can switch back to the mobile and see whether we are able to browse the internet or not. So we'll be moving to the second window here. So now I connected to my mobile. So you can see there is no Wi-Fi right now attached. So what I will do, I will try to configure it using a couple of special identities. So here we have to use a method, authentication method as AKA, which will be used, your SIM will be used to authenticate. So you can see that the Wi-Fi is already latched and there is no username and password asked. So directly your SIM will be doing the authentication with your existing MNO core via Magma. So now the Wi-Fi is latched, and now I'm going to see if I can browse the internet. Yeah, so that is, so we are able to get into the internet. So next, we'll move to the next slide, where we will be talking about reference links and the final part. Okay, so let me switch to the next final slide. Okay, so to summarize here, so what we are trying to do, we are solving for heterogeneity. The first thing is like flexibility. So modelizing the network into fast fabric and policy rich edge to maximize the deployment and business models. That's what we are trying to solve here. The next is hierarchical orchestration. So distributing the edge service requires hierarchical orchestration. So that we are achieving here. And next will be the consistent runtime, where we are using Kubernetes-based edge clusters, which offers a consistent runtime for edge service. So if you want to get involved, here is the link. Get into the github.com/magma, where you can collaborate with us. So before moving to the QA, so here are the few more groups which you want to get involved. So you can just join the Google groups which are part of Magma. And before moving to the QA session, I just want to talk about container lens. So Lens is a Kubernetes IDE that simplifies Kubernetes for application developers. So Mirantis is highlighting Lens at KubeCon. You can view a demo at our booth or download it from k8lens.dev. Thank you. We'll move on to the QA part.
Thanks, everybody. So I think we have one question that I think I know the answer to. The other two I'll probably have to sync up offline on Slack. So the first one is around, I haven't seen any new commits in the Wortlet project since December 4th, 2019. Is the project still alive? I believe it's still alive, but for the integration that we're exercising here with Magma and certain components that require a custom kernel and a VM, mostly for NIC offloads, we're switching to KubeWort. And so that's mostly for both performance as well as driver support for certain use cases. But going forward, we're hoping that we can natively express all of those things through the Kubernetes runtime itself. Any other questions? Cool. We'll hang around on the Slack channel as well. So if folks want to understand how better to engage with Magma or the Kubernetes integration with Magma, we can follow up on Slack as well. Yeah, I think we're almost out of time. Thanks, everybody. And we'll be on Slack in case folks have any questions. Actually, we just got in a question. How is the LCM of the application is managed by Magma? So that's the hierarchical orchestrator part of the equation. So yeah, so we can give you a more detailed answer on the Slack as well. Thanks, everybody.
Yeah, thanks everyone.